The rules for exponents still hold when exponents are negative. Here we have common bases in a quotient situation, in other words, dividing one another, where we can use the quotient rule, which is taking that common base and subtracting the exponent in the denominator from the exponent in the numerator. So we have -5 minus the exponential power in the denominator. Minus a minus is plus, changing the subtraction into addition of the opposite. And if we simplify, we end up with x to the -5 plus 7, or second power. In this next example, we have 1 over n to the -4. Think about the negative exponent rule. We have a to the -n is equal to 1 over a to the n. So we're taking this negative exponent and putting it in the denominator. Well, if we go this direction, this then, treating it as though it were our n, is going to go up here to that base, the opposite of what that power is. Here's our opposite of that exponential power. And here, now looking at that, we have a -1 times a -4, which leaves us with n to the 4th power. If you look at where we were and what we ended up with an equivalent expression, bringing that factor with its negative exponent to the numerator ultimately results in a positive exponent. Just like when we had a negative exponent in the numerator, we took it to the denominator to make it positive. The justification here is using that negative exponent. One more example, similar to the last one. I'm going from the fraction form to a quantity that has that base in the numerator. I'm taking that power and putting it with that base, the opposite exponential power of it. Minus a minus, or a -1 times a -1, is 2 to the 1st power, or simply 2. And again, if you notice, we went from a base with a negative exponent in the denominator, ending up being equivalent to the base with that same exponential power in the numerator with a positive exponent.